Hi everyone, my name is Sarah Karlekar, and my project is about exploring concussions in autistic youth. So I chose this topic because I wrestle in high school and I've come close to having a concussion before. I've had a lot of teammates that have had concussions. So I was kind of interested in this topic, and then I had a lot of experience working with kids in both volunteering in a pediatric office. Um, so kind of a combination of all these factors piqued my interest in this topic. And I'm also just very interested in neuroscience and biological sciences. So yeah. So a lot of young athletes, aspire to have a career in athletics, but concussions can always pose a significant risk and cut their career short. So, research indicates that almost 20% of all high school athletes in contact sports get a concussion every year. And understanding effects tailored to different groups, such as autistic individuals, will help healthcare professionals recognize and diagnose concussion symptoms that may present differently in different individuals. So, what is a concussion? A concussion is a form of mild traumatic brain injury where the head faces a forceful impact. And immediate symptoms may include slurred speech and dizziness, while long-term effects can have significant effects on, cognitive function, memory, and concentration. So in general, younger individuals can experience longer recovery times and more severe effects, including increased deficits in gait and balance control, which is related to the way someone walks. And they're also more susceptible to more concussions in the future. So the brain regions concussions primarily affect include the white matter, which is like at the top of the brain, it like covers the brain. Um, and the frontal lobe, the prefrontal cortex, the temporal lobe, and the midbrain. So the prefrontal cortex is responsible for voluntary movements and higher executive functions, while the hippocampus of the temporal lobe is mostly related to balance and gait. And research indicates that concussions are generally related to a degradation of white matter integrity throughout the brain. So, what are the long-term behavioral damages related to concussions? So, post-concussion syndrome is like a syndrome that happens like after one experiences a concussion, and it includes a variety of symptoms like headaches, emotional instability, difficulty concentrating, and more. And it typically only lasts a few weeks, but children that have concussion experienced weaker cognitive skills, especially in verbal memory tests, and also reduced memory. So, brain development in autistic individuals is inherently different than in neurotypical individuals. Notably, they have reduced brain tissue in the cerebellum, an enlarged amygdala, and altered gray matter cortical thickness. And they also have differences in the way water diffuses through the white matter, which I'll cover in the next slide. But they also have larger brain volumes due to rapid cortex expansion in infancy and early childhood. Um, so autistic individuals have a significantly reduced fractional mesotropy, increased mean diffusivity, and increased radial diffusivity through their white matter. So all of these three characteristics basically describes how water diffuses in the white matter. So fractional mesotropy is the direction in which water diffuses. Mean diffusivity is how much water diffuses, and increased radial diffusivity is similar to like examining how the water diffuses, like it's basically how it diffuses perpendicular to the main direction of diffusivity. So this all might seem a little bit random, but when you look at the implications of it, it actually means a lot because reduced fractional mesotropy means, reduced myelination, reduced organization of the white matter and all like the nerve fibers. So when you're increasing mean diffusivity, you're increasing the amount of volume of water that's diffusing around an already weak white matter, and this can kind of lead to more profound effects of a concussion. And the corpus callosum also shows degeneration, which is the corpus callosum is what separates the brain into like different hemispheres, which lead to decreased brain connectivity, which can lead to more implications further on. And yeah, and then also another study showed that the nerve fibers in autistic youth are structured differently from neurotypical individuals. So concussions lead to decreased fractional anisotropy in brain regions crucial for communication throughout the brain and motor processing. But mean diffusivity increases in areas responsible for eye coordination, ocular reflex, motor control, and language processing. So these alterations suggest reduced water diffusion restriction in white matter tracts and increased extraneuritic water volume, which is what's related to the mean diffusivity. So concussions generally have a complex relationship with those with autism because there's no clear connection, but typically concussions decrease the fractional anisotropy and increase the mean diffusivity in white matter throughout the brain. And these might be more prominent in those with autism spectrum disorder because these differences in fractional anisotropy and mean diffusivity are already um, bigger in those with autism, and having a concussion might just increase the differences in those with autism too. And this extraneuritic water volume is linked to long-term neuroinflammation, which not only affects them right after the concussion, but years after the concussion occurs. And this can affect growth factors, learning, and memory. So, understanding the impact of concussions on white matter structure, especially its fractional anisotropy and mean diffusivity, is significant. The effects may be more pronounced in individuals with autism spectrum disorder because of the inherent differences in the water diffusivity between those with autism and neurotypicals. And this just really highlights the importance of understanding and mitigating the potential long-term consequences of concussions, especially in those with autism, to support their cognitive development and functions, because autistic individuals may need different treatments, including longer recovery time, more monitoring, or specialized therapies. That's about it. Thank you so much.
Thank you. And that's a wonderful deep dive in the topic. And let's take a moment for audience question. Okay, we have one question here already. Do any of your findings make you hesitant to continue wrestling? That's an interesting question. Thank you, Veronica.
The answer is no, because I think concussions, like the risk of having a concussion, it comes with every sport, and it's just like part of the sports. Yeah, it's just a part of the sport. So the answer is no. And then, what are some long-term or incurable effects
Yes,
on the brain after a concussion? Yeah,
concussion.
mainly what I
Yeah.
found was differences in like cognition, like motor skills, memory, all of that. Mainly things that are connected to the prefrontal cortex, and then also like the hippocampus. So that includes like differences in gait, balance, motor skills, all of that.
Mhm. And I also have a question. So I wonder why did you choose to focus on the autistic population? The, like, how did you to research on
Yeah.
both those people? Yeah.
I just felt like that population was kind of underrepresented, and I kind of tried to do a lot of research before, and I didn't find a lot of material. So, and I thought that there was already a lot of material on like how concussions affect neurotypicals, so that's why I was interested. And then I also like worked with a lot of autistic children through like volunteering, and then also like I worked at a pediatric office, so I encountered a lot of autistic children, and that kind of made me interested in that population. So yeah.
I see. And we have one more question. Are there any additional differences or complexities associated with concussions when you factor in gender?
I personally didn't find any articles that factored in gender when examining concussions, but generally, like if there are any inherent differences between the male and female brain, especially like concerning the white matter, there might be, but I wouldn't really think so because I don't think there's significant differences in white matter between males and females.
Yeah. Okay. Thank you so much, Sarah.